Hello, this is Akshay with another video here, and today we are going to take on a numerical problem based upon electric power. So let us just go through this very numerical problem. Two lamps are given here. One rated 100 baht at 220 volt, and that's the rating. Yes, it is 100 baht at 220 volt, and the other bulb is 60 baht at 220 volt. Are connected in parallel. That's the type of combination they are in, connected in parallel to the electric main supply. What current is drawn from the line if the supply voltage is 220 volt? So two or three things we firstly just need to understand. That is, yes, this is what you are looking at, 100 baht at 220 volt. That's the current rating, or that's the you can say power rating for a given electric bulb here. So what power rating tells us that how much energy is being consumed, rate of consumption of energy at a definite value of potential difference. For example, the power rating of this very bulb is 100 baht at 220 volt. This means that this very bulb will release or consume 100 joule energy in 1 second when it is subjected to 220 volt. So that is known as the power rating. Another bulb is 60 baht at 220 volt. It means when this very bulb is subjected to 220 volt potential difference, then it will release 60 joule of energy in 1 second. So that's its power rating. Remember, the voltage which is given in the power rating, it's not the operating voltage. It is not the actual voltage. This is the voltage which states that is if and only if this very bulb of 100 baht rating is subjected to 220 volt potential difference, then it will release 100 joule of energy in 1 second. And if it is not subjected to 220 volt potential difference, then it's not gonna release that much amount of energy in 1 second. So that's the one thing we need to understand. So the voltage which is given in a power rating, it is different than the voltage which that bulb is gonna have in actual practice. So the voltage in actual practice is coming from the main supply line, and that voltage it is given here, it is 220 volt, and it shows that this is the operating voltage or actual voltage which this bulb is gonna just subject to. So let us just go through now this very numerical problem. Two lamps are, one lamp is this one, second lamp this one. Okay, both are connected in parallel. Oh yeah, that's what we know. One end of these two bulbs are put to one common point, and the another end of these two bulbs, yes, that's connected to another common point. So we have got a parallel combination here, and then it is connected to the electric main supply line, and it is, here it goes, and it is electric main supply line there. What current is drawn from the line? Yes, that's the point. What current is drawn from the line? From the line means from here, the source here. This is the source, main supply line. What current is being drawn from the line if the supply voltage is 220 volt? So it means what kind of a current it's asking? It is being asked that the current coming from the main supply line. Let me tell you, the current coming from the main supply line is the total current flowing in the circuit. So it means we need to find out the total current I, because that's the current coming from the main supply line. So question is quite clearly mentioned here, that is we need to find out what's I here. That's what our question is. Since this combination is in parallel, and we know that is in parallel combination, current has got many pathways to flow through. So there are two bulbs available here. It means this very current, that is the total current coming from the main supply line, will go through these two paths. One through 100 baht bulb, and the second one goes through 60 baht bulb. It means if we are in a position to find out I1 and I2, let I1 is the current flowing through first bulb, and out I2 is the current flowing through 60 baht bulb, that is second bulb, then I1 plus I2, as we have learnt in a parallel combination, that is in parallel combination we have learned, and if you have forgotten, please watch that very video. That resistances or resistances in parallel, or a combination of resistances in parallel, and thereby one point was just quite clearly mentioned there, that is in a parallel combination the total current coming from the main supply line got distributed among the number of resistors. So the same is here. This total current I is going to be distributed among these or between these two. You can say that is a bulb here. So one bulb is getting I1 current, another one is getting I2. So what we are going to do, we are going to find out what is I1, then we will find out I2, and finally we will write, since this combination is in parallel, it means I1 plus I2 is equal to the total current coming from the main supply line. So once we know I1 and I2, we can find out I. So that's how we are going to proceed in this very numerical problem. So roadmap is quite clear here. Only we need to just walk on that very path. So let us walk. So two lamps, one rated 100 watt at 220 volt. So here it is, rating of first bulb, and what's the rating? 100 watt at 220 volt, and I have mentioned what the rating is all about. So this implies that power of first bulb, that is P1, and it is equal to 100 watt. And but this 220 volt is, this is the voltage present in, you can say that is a rating there. So that means this very bulb is gonna release 100 joule of energy in 1 second, then it is subjected to 220 volt potential difference. Remember, this is not the actual voltage or operating voltage. Anyway, that's the P1 here. Number 2 is that rating of second bulb. And what's the rating given here? 60 watt at 220 volt. And what will it give to us? That is, yes, power of second bulb. And it is second bulb, so it's gonna be P2, and it is equal to 60 watt. Next is being asked that are connected in parallel. They are connected in parallel to the electric main supply line. This is the electric main supply line. What current is drawn from the line? Yes, the current drawn from the line is the total current flowing in the circuit. So this is what asked here. Current drawn from the line. And you know what is this? This is total current flowing in the circuit, total current, and that total current is denoted by I, and it is going for question mark, or we will say here that is I is question mark. That's what we are going to find out. That is the total current I. Okay, now next is if the supply voltage 220 volt. Yeah, this is the supply voltage, this is the operating voltage, this is the voltage under which these two bulbs are gonna operate. So it is called supply voltage or operating voltage. We can write it as supply voltage, or it can be written as operating voltage, and it is V, and it is here 220 volt. So everything is there as far as numerical problem is concerned. Firstly, write down what's given here. Secondly, watch the units. Units are same here. Power is given in watt, so is the case. And yes, voltage in V. Yes, it's okay. Now we are gonna just apply the formula here. Firstly, and I have told you that is we are gonna find out I1 current flowing through first bulb, and we know power is 100 watt and voltage it will get 220 volts. Since this combination is in parallel, and we have learnt in parallel combination that is each and every conductor or resistor will receive the same voltage as that of the main supply line. Since the voltage of the main supply line is 220 volt, it means the bulb first will also receive 220 volt, as well as the second bulb will also receive 220 volt. So we know the kind of voltage they are receiving. First bulb is receiving 220 volt and its power is 100 watt. So we will apply the formula of electric power. P, that is the power, is equal to voltage multiplied by current, that is P is equal to VI. Voltage we know, potential difference is known to us, that is 220 volt. Current we are going to find out. Power is known to us, that is this is 100 watt bulb. So power, voltage, both are known to us. Current can easily be just calculated out there. So that's how we are going to proceed further. So firstly we will find out I1. Thereafter we are going to visit I2. So the current flowing, yes, current flowing through, yes, first bulb I1, and I1 because it is the bulb of 1, so it is I1 and its question mark. So as we know that, now we are going to solve it. As we know that, yes, according to PAP, that was the formula we have learned. P is equal to VI. Here it is. That formula we are going to use because we know what's power. Yes, we know what is voltage. We can easily find out I. So here, as we know that P is equal to VI, but remember it is the first bulb. The power is going to be P1. Voltage remain the same, that is V, but the current is taken as I1 and it is I1. Or I1 is equal to P1 upon V, or I1 is equal to P1. What's the power of first bulb? 100 watt. It is 100 watt and divided by V, and it is 220 volt. So it's cancelling here, and it is 11 and it is 5, and we will get 5 upon 11 ampere. That's the current flowing through first bulb, and it's being written here 5 upon 11 ampere. That's the first case. Now we are going to find out the current flowing through 60 watt bulb here. Here it is. So current flowing. Now we are going to come across second bulb here. Same the way we are going to do it. So current flowing through second bulb, and it is denoted by I2 and going for question mark by using this formula. This very formula is gonna put into play here. So by using yes, P2 power, formula is P is equal to VI. This is the you can say the mathematical expression for the power, and power is equal to voltage multiplied by current. Too many formulae we have learnt over there as far as electric power is concerned, and during that very learning I had told you that is, yes, any kind of a formula can be used, or the given formula can only be used depending upon what kind of the physical quantities are being given in a given numerical problem. So since there is a voltage and you can say power is given, we can easily use this very formula to find out the current. So here it is, P2 is equal to V, potential difference remain the same thanks to the parallel combination they are in, and it is I2, or I2 is equal to P2 upon V, or I2 is equal to, what is P2? It is 60 watt, and V is equal to 220 volt. So 0 0 cancel, it is 3 and it is 11. So therefore I2, that is the current flowing through the second bulb, is equal to 3 upon 11 ampere. Here it is, 3 upon 11 ampere. So we got both the currents here, I1 5 upon 11 ampere, I2 3 upon 11 ampere. Now we are gonna just enter into the final stages. Let me wipe it away. Yeah, here it is. Okay. Okay. Now here we will write that since the combination is in parallel, this implies that yes, I is equal to I1 plus I2, because current is gonna be distributed among the number of resistors. Only two bulbs are there, so it's gonna be bifurcate here, I1 in the form of I1 and I2, and when you are gonna add these two, they are gonna stand equal to the total current coming from the main supply line. So here it is, I is equal to I1 plus I2, or I is equal to, but is I1, it is 5 upon 11, and I2 it is 3 upon 11, and it's ampere. So therefore current flowing through, or total current we can say here, or current, the current is drawn from the line, current drawn from the line, that was the question. Current drawn from the line, that is I is equal to 538 upon 11 ampere, and it can be written as 0.73 ampere. So that's the total current I, that is 0.73 ampere. So that's how you are gonna just take on the numerical problem. So once you know the concept, it is easy, far more easy to apply those concepts in real practice. Yes, provided you know how to put them into use. Just previous knowledge is needed. Since this was a parallel combination, you have to use one or two mantras coming directly from parallel combination. And one more thing is that you must know that how to find out the power, if the two how to find out a given quantity if the two physical quantities are over given here. So we are gonna find out the current I. So power was there, voltage was there. It was easy job to find out current I, and that's how you are gonna proceed through the numerical problem. So that's it here.